Welcome to Neural Designer University. In this video, we'll explore input correlations. Before building a machine learning model, it's essential to understand how your input variables relate to each other. Correlations help us detect redundancy, simplify the model, and often improve training performance. Rather than going through the theory upfront, let's learn it directly through an example using Neural Designer. Let's start with the blood donation example. We open Neural Designer and from the menu on the left side of the screen, click on the Examples button. All the available examples are displayed, and we select the blood donation example. Click on Calculate Input Correlations in the Task Manager tab. A window will appear where you can choose the maximum number of correlated pairs you want to display, and you can also select whether to compute Pearson or Spearman correlations. This choice matters because the method should match your data. Pearson is ideal for measuring linear relationships between continuous variables. Spearman, on the other hand, is more flexible. It measures monotonic relationships, making it useful when the data contain outliers, exhibit a nonlinear trend, or are ordinal. Choosing the right method helps you capture the true nature of the relationship between variables. It's worth noting that the method used to compute the correlation also depends on the type of variables involved. For continuous variables, Neural Designer uses linear correlation. When one or both variables are binary, it applies a logistic correlation instead. Neural Designer automatically chooses the appropriate method based on the variable types, so you don't need to configure anything manually. Once you confirm, Neural Engine will compute the correlations among the input variables and automatically open the Neural Viewer. You'll first see a table listing the most significant correlations between input variables. The number of pairs shown depends on what you selected earlier. To read these numbers, remember that input correlations measure how strongly two variables move together. The correlation value ranges from -1 to 1. A value of 1 means perfect positive correlation. 0 means no relationship between the input variables, that is, the variables are mainly independent, and -1 means perfect negative correlation. When the correlation is high, whether positive or negative, it means the two variables are carrying very similar information. Neural Designer also displays a correlation matrix that contains all pairwise correlations among the inputs. In this matrix, you can quickly identify strong positive relationships and strong negative relationships, usually in greenish colors, and variables that are weakly related to all others in reddish colors. For example, in this dataset, you might notice a strong positive correlation between frequency and time. This means that donors who have been in the donation program for a long time also tend to have donated many times. In other words, the longer someone has been a donor, the more donations they have accumulated. Both variables increase together. Now that we've seen the results, we can see why correlation analysis is so useful. It helps answer two essential questions. First, are any variables redundant? If two inputs are highly correlated, for example, 0.95 or higher, they are essentially providing the same information. Keeping both increases model complexity without improving accuracy. Second, are there variables that could cause instability? Perfect or near-perfect correlations can lead to multicollinearity, slowing the optimization process and making training less reliable. By identifying these patterns early, you can simplify your dataset and improve model performance. That concludes our section on input correlations. In the next section, we'll explore input target correlations, which reveal which features are most relevant for predicting the target variable.